Hello everyone, I'm Sunita Swain, Faculty Data Science at Techno India University, Kolkata. Today, I'm going to discuss the acid properties in DBMS. So already we have discussed the basic of DBMS, and DBMS is having the property of acid. So database management system, the property acid, to maintain and to remain integrated, we need to follow this acid property. So DBMS is the management of data that should remain integrated when any changes are done in it. It is because of the integrity of the data is affected. Whole data will get disturbed and corrupted. Therefore, to maintain the integrity of the data, there are 4 properties described in the database management system, which are known as the acid properties. The acid properties are meant for the transaction that goes through a different group of tasks. And there we come to see the role of the acid properties. In this section, we'll learn and understand about the acid properties. We'll learn what these properties stand for and what does each property is used for. We'll also understand the acid properties with the help of some examples. Obviously, through examples, we can understand the terms or different properties of acid, property of DBMS more clearly. So, one by one, we'll discuss. So, acid stands for atomicity, consistency, isolation, and durability. So, what is these terms are? First one is atomicity. The term atomicity defines that the data remains atomic. It means if any operation is performed on the data, either it should be performed or executed completely or should not be executed at all. It further means that the operation should not break in between or execute partially. In the case of executing operations on the transaction, the operation should be completely executed and not partial. So, by the example, we can understand the atomicity property more clearly. So, here one example has been stated. If Remo has account A having $30 in his account, from which he wishes to send $10 to Shiro's account, which is B. So, one person wants to send a certain amount to another account. So, in account B, a sum of $100 is already present. When $10 will be transferred to account B, the sum will become obviously $110. Now, there will be 2 operations that will take place simultaneously here. One is amount $10 that Remo wants to transfer will be debited from his account A, and when it is debited, obviously it has to be credited in some other account. That's what the credit amount $10 will be credited in account B, which is of Shiro's. That is, the first operation of debit from A executes successfully, then only the credit operation can be possible. But the credit operation, however, fails. Thus, in Remo's account A, the value becomes 20, and to that of Shiro's account, it remains $100 as it is, how it was previously present. Means this is one kind of inconsistency occur during transaction. Somebody else has wants to credit something, and from the particular account some amount has been debited, but still that amount he wants to transfer to some that destination account holder's account, it is not having credited. So as it is, the previous account is there. So row debited successfully, but credit is having certain failure of different kinds of glitches might be there. So partial execution has been occurred from account A, but half of the transaction has not been occurred. So this partial execution, no atomicity execution termination. So this transfer process is incomplete. So in this above diagram, it can be seen that after crediting $10, the amount is still 100 in account B. So it is not an atomic transaction. So this is one best example when different types of account transaction we are doing, this type of operation, if it is not successful or partially successful, then it is called as failure in atomic transaction. See another diagram. This image shows the both debit and credit operations are done successfully. Thus, the transaction is atomic in nature. So, understood what is the concept of atomicity? Because when we are maintaining the database, so the database management system says it should be atomic in nature. All the operation must be atomic. So any kind of operation we are doing, it should be complete in nature. When certain kind of operation we are executing, it means somewhere else, if we have deleted or we need to cut some your fields or particular columns from one database where it has been pasted. Like that, here, the complete database transaction needs to be atomic because of this purpose. Otherwise, the transaction is not complete. Will not use this particular procedure successfully. Means what is the purpose of database management system is not done successfully. So acid property, all the 4 points, if successful, then we can call it as the database is managed properly. We are using the proper database management tool. That's why it is happening like this. Otherwise, if any inconsistent information will be gathered in the stored procedure, it means our procedure is not successful. Entire database operation is not successful also. Some inconsistencies if exists. Let us come to the point C, that is from acid property, the second one, that is consistency. So the word consistency means that value should remain preserved always. So values should remain preserved. So the integrity of the data should be maintained, which means if a change in the database is made, it should remain preserved always. In the case of transaction, the integrity of the data is very essential so that the database remains consistent before and after the transaction. The data should always be correct. So this is one example. Now from I see that second point, how the consistency feature is adopted. What is this consistency feature is in database terminology? See, this is the account A, B, C. So before the transaction that is $300 were present in A, debit to B means from B it has been debited means it should be credited to B as $50. So it is shown already the $50 has been credited. So debit from $300 from A means now available balance should be $250. Suppose again another debit to C, that is $20. So now available balance in account A should be $230. And in C, one credit amount should be $20. So in C, before transaction, it was $50. Credit amount is $20. So available balance should be $70. Before transaction, account B is having $100. Credit amount is 50. So available balance should be $150. So this is one simple transaction having three accounts, different types of credits and debits, different credit debit instances. So when any debit account, now the some amount has been debited, means the available balance must be proper. And where it has been credited, that balance must be updated. Available balance in the second account must get updated so that the data will be called as consistent. So in this figure, we need to explain how the data consistency feature is adopted in database environment. So the data base is consistent in nature, means whatever transaction we are making, it must get updated in the master database instantly. Or what is the actual stipulated time period for this kind of transaction, it should be done accordingly. If it is not done, suppose 50 rupees has been debited and available balance is rupees 250, but it has not been credited to B as 50 rupees, means the final value, available balance, though it is correct, but available balance of B will be incorrect. So it is called as inconsistent information in the database. So the data is inconsistent when the debit operation executes and it will not be consistent. So whatever operation we are making over here, according to the actual purpose of using database management system, our actual purpose is to make the particular transaction successful. Obviously, the request has been processed. But thing is, when we are talking about the real database management system tools, so the particular database management system should have this ACID properties. It means it should follow this atomicity, consistency, isolation, durability. These properties should be there, otherwise we cannot call it as one database management tool. Understood? The second point, every database management system follows this ACID property. Next, come to the isolation, third property. The term isolation means separation. So in DBMS, isolation is the property of a database where no data should affect the other one and may occur concurrently. Means the data should be isolated. It should not affect one another. Sometimes concurrent operations are going on in the database, but still all types of transactions should be isolated. In short, the operation on one database should begin when the operation on the first database gets complete. It means if two operations are being performed on two different databases, they may not affect the value of one another. In the case of transactions, when two or more transactions occur simultaneously, the consistency should remain maintained. So any changes that occur in any particular transaction will not be seen by other transactions until the change is not committed in the memory. Like suppose one example, we are having 100 rows in the database and I have performed certain deletion operation or insertion operation. So after deletion, suppose 5 rows, it must be committed that we are having 95 rows at the end. And the total count of the rows or count of the total IDs or names or total account holders, anything else, it is of 95. Then any other insertion operation we are performing later on, it should be updated accordingly. So each and every transaction is complete, then another transaction should be performed. If concurrent operations are going through from one particular account, if any kind of monetary transaction we are doing, there also same thing should be adopted. Hence, it should be isolated operation. If two operations are concurrently running on two different accounts, then the value of both accounts should not get affected. So the value should remain persistent. As you can see in this above diagram, this account A is making transaction T1 and T2 transactions to account B and C, but both are executing independently without affecting each other. So we see in this proper example, this diagrammatic representation of different account information. We are having three accounts A, B, C. So A, before transaction, it was $100, debit to B, so $20. Now available balance should be 80 rupees. Debit to C means another transaction is going on and the available balance should be 60. Accordingly, this transaction T1 is performing to account B and the transaction named T2 is performing in account C. Concurrently, this debit operation is done in transaction 1, transaction 2, two different accounts. But independently, T1, T2 transactions are occurring by account A. Each and every operation is not overlapped. Independently, the transaction 1 is going on. Independently, transaction 2 is going on. So, this is called as isolation operation. So, isolation property in database management system. Then come to the durability. Durability ensures the permanency of something. Means permanently it has been committed to the database. So in terms of database management system, the term durability ensures that the data after the successful execution of the operation becomes permanent in the database. And the durability of the data should be so perfect that even if the system fails or leads to crash, the database still survives. This is called as durability in database operation. So data should be durable, means obviously when we are using database management system, we are dealing with the security of the data. This is one record keeping system, and we are keeping the data for the particular organization or for personal purposes. So accordingly, this is the responsibility of the recovery manager for ensuring the durability of the database. If any kind of technical glitches, if the system crashes, then how this particular recovery procedure will be undertaken. So for committing the values after certain operation, the commit command must be used every time we make changes. So that in the master database, any type of operation we are doing, we are dealing with any sort of operation, it should be saved. Commit means, say for an example, in a particular document we are preparing. So during preparation, suppose I had updated something in the stored document. Means it must be saved. Otherwise, if power fails or any kind of technical glitches, the document, any kind of updation I have made, it will not be updated. It will remain as it is, or the previous operation till which it has been saved. It will remain like that. So, like the save operation in documents, here in database management system, this is called as the commit command. So it must be used every time we make changes. Therefore, the ACID property of DBMS plays a vital role in maintaining the consistency and availability of data in the database. So, it was a precise introduction of ACID properties in DBMS. We have discussed these properties in the transaction section also. So, the examples we have stated here, that is for monetary transactions, account transfers, credits and debits, because By this, you can understand the practical purpose of ACID property. Means different transactions. This is not only the bank transactions, any kind of database transaction. We can understand it in better manner when this monetary transactions, small credits, debits with different accounts, if we'll discuss, then it will be more clear. That's the reason behind stating this examples. So with each and every property of acid, we have given the examples of monetary transactions. So at last again, I'm repeating the ACID stands for atomicity, consistency, isolation, and durability. And accordingly, the different properties, each and every property of the database management system should be followed with database management system tool. Means the kind of operation we need. What is the actual purpose of the database tool? It will be fulfilled with the use of atomicity, consistency, isolation, and durability properties. So, why this acid property is so important? Because we need to make our database proper. It should be properly organized. If any kind of database operation we are doing and it is not reflecting in the stored database, it means data is inconsistent. We are not using the proper information or not, or what is the purpose of record keeping system, it will not be fulfilled. So we should understand what is this acid property is, and these particular properties defines different types of database operation and how it gets updated instantly after each and every operation. It should be concise. It should be atomic in nature without inconsistency. Each and every operation should be isolated, means different transactions should not be overlapped. Each and every transaction should be isolated one. Each and every transaction should be complete. And finally, it should be committed. It should be properly updated. Whether it is a deletion operation or insertion operation, no issues. All types of operation must get updated in the master database. In database, that save operation is called as the commit one. So, the data must be durable. Means that is one administrative tool. If any kind of data loss occurs due to any technical glitches, machinery failures, then how it will be recovered? Because database management properties, database management system properties, when we discussed, that is about the durability, means it should be consistent without any kind of issues, and data must be secure. And the security feature will be adopted by the different types of recovery procedures and along with the authenticity of the users and different types of access given to different environment, means different workstations, how the different database users, how they are using this. So, in today's class, we have discussed the most important concept of database management system, that is acid properties. And this acid property used for all database management tools. Without this, the database management system is not organized. Thank you.